Assalamualaikum. So we meet at 3.5 power losses induction machine and its efficiency. So there are losses happen in the induction machine such as copper losses. Copper losses happen at the stator, rotor, core losses and mechanical power losses due to the friction and windage. So how does this power flow in the motor? So this is the figure of the induction motor that has been separated between stator and the rotor. So the stator, you will having the P stator copper loss, P core, and between the stator and the rotor there will be a PA gap. At the rotor there will be a P rotor copper loss. While converting from the electrical energy to the mechanical energy, there will be a P conversion or P mechanical developed power. After that, there will be a P windage and friction loss, and lastly the P out. So we will go deeply into each losses. So I would like to remind that for induction motor, it will convert from the electrical energy to the mechanical energy. So the P in here should be electrical, and the P out here should be the mechanical. So, since the P in is the electrical energy, so you can use either this formula or this formula. So recall back your three-phase chapter 1. If you want to use the voltage line value, so VT here is actually similar to the voltage line to line. So if you want to use the voltage line value, you should use I line value as well, and obviously you should times with square root 3. Okay, if you want to use the phase value here, or you should use phase value, but you should time with 3. So next loss that will experience by the induction motor is the P stator copper loss. So P stator copper loss can be write as the I1 square times R1. Since this is a 3-phase, so I just times with 3. Next is the P core loss. So P core loss, normally it will given in the questions, but it can be we can search it by using this formula 3 times V1 squared over RC. So next loss will be experienced is the PA gap. So PA gap, you can use either, remember last topic transformer I taught you, atas tolak bawah dapat atas. So you can use either this concept, PA gap is equal to P in minus P stator copper loss minus P core, minus core loss, you will get PA gap. But there is another formula. If you want to calculate the PA gap is equal to 3 I2 square, I2 is I rotor, times R2 over S. Okay. Next will be the P rotor copper loss. So P rotor copper loss, the equation is 3 times I2 square times R2. Or it can be rewrite simplified as S is a slip times PA gap. Okay. Why S times PA gap? Because you look at this formula, it's actually a simplification. Okay, next is the P mechanical develop, or sometimes it can be a P conversion. And now you can use this formula. PA gap is equal to, P conversion. So P conversion is equal to PA gap times 1 minus S, or atas tolak bawah. Okay, remember PA gap minus P rotor copper loss, you will get P conversion. And lastly, P stray. So, not the last one. Okay, P stray is a P friction plus P windage plus P stray plus P mechanical losses. And lastly, you can calculate for P out by using the formula of atas tolak bawah. So P mechanical develop tolak minus P mu, you will obtain P out. So this slide is actually the same as previous slide. So special note on the P core. The core losses do not always appear after P stator copper loss. And P core, P friction and winding, P stray are sometimes lumped together and called rotational losses, P mu. So the efficiency of the induction motor, it is similar as the other efficiency for the machines. which is efficiency is equal to P out over P in times 100. We will continue about the torque equation and maximum torque. So torque equation can be written as a P over omega. Omega is actually a rotational speed in radian per second. P here is the power. So how to get this equation? It's actually by converting the n becoming omega. So omega is actually 2 pi n over 60. So if we inserting this omega into this equation, you will get the torque is equal to P over 2 pi n over 60, and eventually you will get 60p over 2 pi n. N is the speed. So there are various of torque that you can calculate for induction motor, either mechanical torque, output torque, starting torque, or maximum torque. So for the mechanical torque, you will use Pm, which is P mechanical develop or P conversion, over omega R. Okay. For output torque, you will use P out over omega R. Notice the difference of the power that they will use. For starting torque, you will use this formula, whereby the value of K, you need to use this formula. And the maximum torque is also known as the pull-out torque. You will use this formula. I will continue the starting method and speed control. There are various types of the starting method for induction motor, such as direct online starter, star delta starter, auto transformer starter, and stator resistance control. So you can go through my notes to understand how the speed of the induction motor can be controlled at the stator and also at the rotor. Thank you very much for your attention.